Our group created a thermoformed jello mold in the shape of a Super G. This project would involve 3 major manufacturing steps: production of the primary mold using additive manufacturing, thermoforming of the secondary mold, and casting the final edible product. First, we decided on sizing. It should be small enough for reasonable jello serving, but not too small that details wouldn't be retained. We were unsure at first whether a positive or negative mold would work better, so we decided to design the box to work with both. For the thermoforming sheets, we needed a food-grade plastic thick enough to stretch around the mold without breaking, but not too thick that it would take too long to heat. Melamine plastic plates were a convenient combination of price, dimensions, and food safety. Melamine resin is a crystalline plastic with a glass transition temperature between 130 and 150 degrees Celsius. The molds are 3D printed, but it doesn't begin to melt until around 200 to 220 Celsius. This is high enough not to worry about accidentally welding the sheet to the mold. Both the negative and positive molds have a positive draft angle of about 2 degrees, as well as filleted edges to make ejection as easy as possible. Small holes were drilled across the negative surfaces to allow the vacuum to pull the sheet in.
To construct our thermoforming box, we started with a 1 inch by 6 inch by 5 foot wooden plank and a square of particle board. We cut 2 6-inch sides and 2 4.5-inch sides so the outside dimensions were 6 by 6. Glued these pieces together first to seal the joint edges, and then screwed them for strength and rigidity.
You said that.
Yeah, I was like, where did these disappeared?
We drilled out a 1 inch hole on the side for the vacuum to attach. Next, we cut 2 6 by 6 inch squares out of the particle board for the top and bottom of the box. We drilled several holes in one of the particle board squares so that the vacuum could flow through there. Then we glued and screwed the top and bottom onto the box.
That's not a bad thing if we're trying to make it airtight.
Yeah.
Just do that one tight. I don't know why one's not coming up. Yeah.
Finally, we made a frame to hold the plastic by cutting a square out of another square of particle board.
Now for the thermoforming process, what worked and what didn't. First, we decided that we didn't need so many holes in our design, so we covered some up with some tape. Another design choice that we made was to try to have the plastic being held down by plastic binders and by adding foam to the outer edges. But the foam prevented the plastic from getting a good suction to the mold, so we had to remove the plastic, and you can kind of see the effects of it in the first 2 trials. After the first 2 trials, we tried using just regular packing tape, and that worked a lot better. To heat the plastic, we used a heat gun. When heating the plastic, at first it would start to bend and warp as it reached the end of the glass transition temperature range, but then it would smooth back out and begin to droop evenly under its own weight. At this point, we would go quickly and try to do the vacuum suction itself by quickly moving the plastic over the mold.
On the first attempt, the plastic sheets were not heated enough and the plastic did not stretch around the mold.
That wasn't ready enough.
On the second attempt, the plastic sheets were still not heated enough, but more vacuum holes were added to the center to emphasize the detail inside of the G. On the third attempt, the plastic was heated to a good level, but one edge became too hot during the suction process and the plastic tore.
Now get on the top.
On the fourth attempt, the plastic was well heated and stretched nicely around the inside and inside of the face of the mold, but was difficult to remove because the plastic was slightly stuck to the mold. The The fifth attempt came out the best because we sprayed a little silicone lubricant on the mold before and it popped right out when we thermoformed around it. We tried thermoforming the negative mold, but the plastic was not able to stretch the depth of the mold without tearing. Maybe with a thicker gauge sheet, the negative mold could have been viable, but the positive one served its purpose well.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.